Okay, good afternoon. So today's lesson is all about how do we make our code easier to understand. That might not sound all that important, but it's absolutely essential. In the GCSE computer science, you write code, you debug code, and the code that you debug is often yours. But in the real world, you're working in teams, and those teams might work on, I was going to say different planets, on different continents. They might speak different languages, and it's absolutely essential that other people can debug and understand your code. And even if it's just you working by yourself, when you come back to a piece of work that you started one day and you come back to it a month later or a year later or a decade later, you need to be able to understand the thought processes. So how do we get code to be readable? We want to have a quick recap on relational operators in both flowcharts and code. We need to build on if and else to add in those elif statements so that we can do selection so that our code can make choices. And then we want to use a range of approaches to make sure that our code is easier to read. We talked about selection before, where we have a choice. In your homeworks, you were very good at using the right symbols, but sometimes in the lesson you forgot to put the arrows on at all, or you put the lines on but didn't put the arrows. Remember, a flowchart shows the flow, and a selection, where you have this diamond shape, selection diamond thing, with a question inside, you need to know which direction you're going. So that's why we have those arrows. If we have multiple possible paths, then we need to think about how we're going to represent that. As in a flowchart, you can only have two outputs, two possible ways that your program can flow. So if you're going to say, how old are you? If you're trying to say, are you under 16 or are you under 18? You can't just say, how old are you? And then say under 16, under 18 or over 18. You've got to split it up into binary questions, as in two possible ways through. So yes or no answers, Boolean expressions, true or false, yes or no. We'll go out this way. I would suggest that this is the wrong shape. I'm going to pause the video and you're going to explain to me why it's the wrong shape and what shape would be better. We've just said that this should be an input-output, which is a parallelogram, not a rectangle, which we use for processes. So here we go. We're saying if you're under 16, oh dear, nearly swore. Recording, shouldn't do that. If we're under 16, we shouldn't be able to drive at all. But if we're not under 16, so we're 16 or over, but we are under 18, so that means that we are 16 or 17. You could drive a moped. Otherwise, so you're 18 or over, and it says you can drive a car. That's what it says with the logic on here. It might be different depending on what country you're actually in. Right, so today we need to look about all of the ways that we can make our code easier to read. We talked about variables already. It's helpful to, instead of just putting seemingly random amounts in here, so if VAT is 20%, you could work out the amount of tax, value-added tax, by saying the amount you've got to pay multiplied by 0.2. That would work out 20% of something. But when you come back to it a year later, you might think, well, why did I put 0.2 in there? What on earth is that? So it would make much more sense to replace it with not 0.2, but a name of a value. And a constant is a name of a value, giving a value a name so that you can use that name, y, so that your code becomes easier to read. You can also use that value, that named value, that constant, as many times as you like. And you then, if you needed to change it, you could just change the value once, and every time you refer to it, like here and here, it just works. So by convention, which means the rules that we just have, constants are in capital letters. You should always put your constants at the top of your code so that you know that they're there if you need to change them later. And you should never change your code, you should never change your constant whilst your program runs. It's fine to change your constant while you're writing the code. You could change that to 0.3 or 0.5. But you should never say sales tax equals input, please enter the tax, because that would make it a variable. And if you needed to do that, it should be in lowercase because it's a variable. It varies, it changes. If it stays the same while the program runs, it's a constant, so you put it in capital letters. Python will still work if you don't follow that convention, but your code will be less easy to understand. That's a convention, a set of rules that we follow to make your code easier to understand. So here we go. Variables in lowercase, constants in capitals, and it should describe the value that you store. Right. This is how your exam board always lays things out. You might have seen code laid out by this. You don't need to have constants like this. You could argue it's a waste of time, and especially if you're doing the Compete with Code.uk typing challenges, it's a bit irritating to type out all these hyphens. But this is how the exam board always does it. They have a block of comments that says, right, all my constants go here, and they define them. And all my variables are going to go here. And it might seem silly to set it to 0 if you're going to then set it to something else later. But they do this so that you initialize the variables. You say there are going to be some variables in your code. So we always do that at the start of your program. Even if it's not necessary for Python, it's good practice, certainly for this GCSE. And then, and only then, do you get onto the main program of the stuff that runs to calculate useful stuff. Notice, above a comment is a blank line. That makes it clear that the comment refers to the stuff underneath. So this is what I mean by white space. It's like a paragraph in English. You split your code up into paragraphs, and each paragraph has a comment above it. You do constants first and then variables. You use white space for paragraphs, and that's what we're doing today, really. I think that's enough for you to get started. Where's the Word document? Here we go. So this is the algorithm. We want to sort packages into green, yellow, and red, depending on their weight. You need to be able to move these. Oh, that's irritating. It's just one solid picture. So you might have to create them yourself with insert shape, or you might have to screen clipping, get them that way, whichever works best for you. So we'll start with trying to represent the algorithm with multiple if statements. So I don't know if this is helpful, but rather than having to create your own shapes in Word or split them up and crop them or screen clip or whatever, I've gone to draw.io. Oops, if I can spell it, draw.io, which I think has been bought out by app.diagrams.net. I didn't realize that. You can make a new diagram, call it flowchart or whatever. Remember, we're saving this into topic 1 and 6, as we always do for our CT1s. And then if you scroll down, you can see all the flowcharts in here, so you can get your terminators. Rounded rectangle for a terminator, there it is. You can get your processes, even calls them the right thing. You can get your decisions, and you should be able to get your inputs and outputs. It calls them data in here, but it's the same thing. And you just click on it and start typing. And then if you click on something, you get a blob to be able to resize, or an arrow to be able to join it up, which is rather nice. They do, they have a terminator. So top tips with this one, please do make sure you label every direction with an arrow. Please make sure that when you come out from a decision, as well as the arrows, you also say yes or no. So that's these yes or no's here. For activity 2, you've just got to think about the order. Now, these can be nice and easy, or they can be rather challenging. These types of questions, you get given some Python code and you've got to put them into the right order, and you've got to sort out the indentation. You should start with the global variables, and you should have the main program, but you need to put all of the other lines underneath into the right sort of place. So we've gone through activity 2. You just need to kind of rearrange them, but make sure you remember the rules, as in every line that ends with a colon, the next line expects to be indented. That could help here. Activity 3, you initialize some variables at the start. You ask a question. You ask another question. Convert it to uppercase using .upper. Wherever you have selection, that's an if statement. Wherever we move to one way, that's going to be indented. So see if you can work out how to do this. Activity 4 is, can you think of sensible names for constants? So this table here helps us here. We've got a couple of things where we say if you're buying shoes, you don't have to pay any tax, 0 rate VAT. If you're buying most things, it's 20% tax. And for car seats, it's just reduced rate, 5%. So that's going to help us here. So let's choose one, for example, here. Trainers, well, I think there's an error in here. I think that should be 20%. So we want to say something like VAT for trainers is equal to 0.2 for 20%. Then you can say the code that you had before, oops, I don't want to copy the whole contents, there we go, I want all of that, but now you can replace that nasty value with something that makes more sense. That's what we're trying to do here. In each case, what is the value? And if you're not sure, look at the table above. Give it a sensible name in capital letters so that you can describe it, for example, pi, and then use pi in your expression. And then activity 5, hopefully this is dead easy for you. This is just like the keywords activity that we do every week in compete.withcode.uk. And we do it for this reason, so that whenever you have an exam question like this, where you've got loads of Python, you think, what does it do? Well, you just go through it and you think, well, where is a constant? There we go, line 1. Where is a variable? Oh, there we go, on line 7. So hopefully you'll be okay at line 5. So remember, please do save the Word document before you submit it. It gets saved into your topic 1 and 6 folder if you're working at school. And then we upload it to Half Term 2 Algorithms and Programming 2 on the VLE.